Okay, students, we're going to review factoring. Steps in factoring. Step one. Now, when it just says factoring like this, that means it's not an equation, so you don't see an equals. For example, 0 equals 7. That'd be solving a quadratic. So we'll also be doing that. So that will be one extra step above this step one once that happens. Okay. So step one, factor out the GCF. So we're just factoring algebraic expressions or polynomials. We're not solving them. Factor out the GCF. 2, factor what's left. Inside the parentheses, if possible. Sometimes that's it. And the other times you can factor still within the parentheses. Okay, those are the two steps in factoring algebraic expressions. So, first one, what's the GCF of 8 and 56? 8. What else? What variables do they have in common? They have one A in common each, not two A's, one A. They each have one A. If one of them had three A's, I can still only take one A out. I can only take the least amount of them out because they have to have, the other one doesn't have two A's and doesn't have three A's. So I can't take two or three out. I can only take one out. So I take the least amount out. And there is no X's in common. So now what you're ultimately doing, if you didn't know, you're then dividing by that GCF that you just took out. You're dividing by 8A. So what is 8AX divided by 8A? That's just X. What's negative 56A divided by 8A? Negative 7. So step one, then I ask myself, can X minus 7 be factored anymore? No, it can't, so I'm done. If it could, I'd go further. Here I can take out a 6 only, and I'm left with m to the 4th minus 10. Then I ask myself, because does m to the 4th minus 10 factor more? No. Now, when we say factor more, we're always talking about factoring over the integers, not over the real numbers. College, they might have you do it over the real numbers, and then that could factor more. But we're not doing that. Your teacher might teach you that in Algebra 2, more than likely not. It might teach you in pre-calculus or calculus, or they might not teach you, period. Okay. All right, factoring trinomials. Remember, trinomials means three terms. Each of these have three terms. Okay. I'm going to teach you the Carlson method. Okay. We're going to go right to the answer. Now, some teachers might argue, oh, that's a common method for these first two, but it really comes into play. It stands out that they haven't seen when it comes down to these bottom two. Okay, so first off, let's just say I have two binomials. If I do x minus 1 times x plus 2, how do I get that answer? I distribute, I get x squared. Okay, then I have 2x, and I have a minus 1x, and then I have negative 1 times, so 2x minus 1x is 1x, and then I have negative 1 times positive 2 is negative 2, and there's my answer. Remember from the last section, every time I multiply two binomials together, I always get a trinomial unless it's set up as a difference of squares. Okay, so now going backwards from this answer, where did this x squared come from? It came from multiplying the first two terms together. So first off, I want to rearrange this in standard form. Remember, standard form is highest degree down. Now it's in standard form. So when I factor it, I get the first two terms, multiply these two together. First two terms gives me that one. So what's going to give me e squared? Only e times e. There's no option there. Okay, well, where did I get my middle term? From multiplying the two outsides and the two insides together and adding them. Okay. Now, in factoring, no matter what method you use, Carlson method or any other method, you're going to ask yourself two questions. What two numbers, multiply to AC, and add, I'm not sure, those are times sign and a plus sign. I'm not just writing out the word multiplication and addition, and add to B. And then you might ask yourself, what's A, B, and C? Well, you have to remember standard form of quadratic is ax squared plus bx plus c. So now you see where A, B, and C come from. A is the coefficient of x squared, also called the coefficient of the quadratic term, because the degree is 2, that makes it a quadratic term. B is the coefficient of the linear term, because it's degree 1, so it's a linear term. So B is the coefficient of the linear term, and C is the constant term itself. Okay. So it multiplies to whatever A times C is. 1 times 48 is 48. And adds to B, negative 16. So what two numbers multiply to 48 and add to negative 16? Okay, that's going to be negative 12 and negative 4. That multiplies to positive 48 and adds negative 16. This is where your times tables comes into play in knowing your integers, which you're supposed to have mastered by 7th or at the very latest 8th grade, which unfortunately most of you don't have down. So it will take you a lot longer to figure out these combinations. Okay, and this is where math builds on itself, and those that choose to not learn their integers well struggle significantly in factoring. Okay, so since these coefficients are 1, I can just add in the negative 12 and the negative 4, and I'm done. I can guarantee I'm right by multiplying this back out. I get e squared, and I have negative 4e and a negative 12e is my negative 16e, and negative 4 times negative 12 is my positive 48 at the end there. Okay, so doing this again here, it's going to multiply to A times C. There's A, 1, and C is negative 36, so 1 times negative 36 is negative 36, and adds to B, which is negative 16. So since it's going to multiply to negative 36, one has to be a positive number, and one has to be a negative number. So in other words, what subtracts to negative 16, but multiplies to negative 36? About negative 18 plus 2. That multiplies to negative 36, and 2 minus 18 is negative 16. So again, since the first terms have to multiply to u squared, that's a no-brainer. It has to be u and u. Okay, and since it's 1u and 1u, I can immediately just write down these numbers of plus 2 and negative 18. By the way, it doesn't matter if I put the negative 18 in the first one and positive 2 in the second. Okay, I'm going to get the same answer. If I multiply that out, it will multiply to this right here. That's how you can check that you're right. All right, so now here's really where the Carlson method comes into play. I'm not going to show you the AC method, which is what the vast majority of teachers in America would show you. If you want a video on it, I have no problem sending you a video. I already created videos on that too. If you want to do it this way, I'm just going to show you the Carlson method. Okay, remember the first term times the first term has to multiply to the first term here. 6z squared. Well, you know there's going to be a z and a z. That's the z squared part. But isn't there two combinations that multiply to 6? Either 6 to 1 or 2 and 3. So I have to figure out which one of those two it is. Okay. Now, I don't do that yet until I've done what it multiplies to and come up with my two numbers. It multiplies to 6 times negative 4 is negative 24, and adds to the middle term b, negative 5. So what are those two numbers? That's going to be negative 8 and positive 3. Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. Okay, so now how I figure out whether it's 6 and 1 or 2 and 3, I figure out which set of these will multiply by another integer to give me those two numbers. And I always start with the highest one because often it doesn't work. Does 6 times an integer give me either negative 8 or positive 3? No, it does not. So that 6 and 1 is gone, so it's automatically 2 and 3 if it factors at all. Then, to get these last two terms, I draw two smiley faces. And so when I multiply 2z times this one over here, it has to equal one of these. And the 3z times this one here multiplies to the other one. Obviously, the 2 goes into -8, -4 times. And 3 times what is positive 3? 1. And there's my answer. Notice I can go right to the answer with the Carlson method. Now, I do have to show these steps here and show that I crossed out one of them, for example. And I have to come up with these two numbers. So we know in math that there's cheating programs out there that will give you the answer right away. And so if you turn in an assignment with just the answer on it, no work, you're getting no credit. In fact, if I see that, I might make you do the AC method on purpose, which is going to show a lot more work than mine. Okay, because you want to be a cheater and get it off somebody else or off a program online. I'll just pop out the answer for you. So you're going to show this work, which is the least amount of work you can show. Okay, or you're going to do a longer work with the AC method. You turn in a cheating paper, you're going to be, from then on, going to be required to do the AC method. So think about it first. Okay. What's this going to multiply to? 15 times 4 is 60, and it's going to add to -16, which then makes it -10 and -6. Okay. Now again, my combinations I multiply to 15 are 15 and 1 and 5 and 3. I have to figure out which one it is. Okay. So which one of these comes? Does 15? I start with the highest number. Does 15 times an integer going to give me -10 or -6? No, it's not. So that combination doesn't work. That's going to be 5s and 3s. Single-unit factors. Okay. Draw my two smiley faces. 5 times what gives me the -10? Because 5 times no integer is going to give me -6. So 5 is connected with the -10, and that's -2. 3 times what gives me -6? -2. And therefore it works. Now again, I can check it to guarantee I'm right by multiplying back out. 5s times 3s, there's my 15x squared. -10s and -6x is -6s10. Oh, I forgot the t's here. -16st. That's why you want to check it, multiply it back out. Make sure you have that. And lastly, -2t times -2t is +4t squared. Okay, so you can quickly check these by multiplying back out. If you have it set up like this, you're seeing it right there. Okay, you got your combinations that are put together. These combinations, that one plus this combination multiplication gives me a middle term. So I've already got it set up of which ones you multiply and add together to get your middle term right there. So that's the Carlson method. All right, next. Factoring difference of squares. Remember I wrote about difference of squares a couple lessons ago. Okay. First thing again in factoring is factor out the GCF. So I take out the 8 and I'm left with n squared minus 9p squared. Now remember the second step in factoring is to factor what's left inside parentheses if possible. Well, one way to know if it's possible is I'd look, if I have binomial, I'm looking to see if both of them, which it is because two terms, binomial, that's a binomial. If it's a binomial, the very first thing I'm looking for is a difference of squares. Difference of squares. Difference just means some subtraction, which there's my subtraction sign. So it's obviously a difference. And now the question is, are the other two terms squares? N squared is a square and 9p squared is a square because it would be 3p times 3p or 3p squared. So that is a difference of squares. So that means it's going to factor into, all I do is take the square root of each. Square root of n squared is n. Square root of 9p squared is 3p, as we just wrote up here. And one's a plus sign and one's a minus sign. Or we did this a couple pages ago. Okay, again, that wipes out the middle term. When the terms are exactly the same and one's plus and one's minus, wipes out the middle term, and therefore I have a binomial. All right, factor out the GCF here, 2. I'm left with 16h squared minus 9l squared. Factor what's left. Is that a difference of squares? Yes, it is. So I take the square root, 4h, one's a minus, 3l, and one's a plus 3l. And there's my answer. Here, I can factor out, or are both these perfect squares now? Yes, they are right away. Okay, but I could also factor out the 1/4. Take out the GCF, 1/4. That leaves me with u squared minus 9. Okay, and then I have 1/4, and both of these are perfect squares, so that's u minus 3 times u plus 3. Okay, it's always a setup. Okay. There we go. Perfect squares in factoring. So if I have a trinomial, the first thing I want to look for is a perfect square, PS for perfect square trinomial. Okay, and how do I look for that? Are the first and third terms, or in this case, the first and last, perfect squares? That's the question you ask yourself. So anytime you see a trinomial, the first thing, and you're asked to factor, this is the very first thing you're going to ask. Is 25v squared a perfect square? Yes, it is, 5v. Is 9 a perfect square? Yes, it is, 3. That's basically almost going to guarantee you it's a perfect square trinomial. So if I go ahead and take the square root of each, so that's 5v and plus 3, and square it, okay. Now if I want to check to see if that works, what's 5v times 5v, 25v squared, 3 times 3 is 9. In my middle term, I multiply the 2 together and double it. What's 5v times 3? 15v. What's doubling that? 30v. And there it is right there. So yes, that factors in a perfect square trinomial. Is that a perfect square? Yes, it is. CD. Is this a perfect square? E squared? Yes, it is. E. E. Okay, and then I take the middle term sign, negative, on both of them. So that's CD minus E quantity squared. Again, I can check that by squaring the first term. That gives me the C squared D squared. I can square the last term, negative E times negative E. There's my positive E squared. For my middle term, I multiply the two together. That gives me negative CDE, and double it, negative 2CDE right there. Okay, so that guarantees me there's my answer. 18 minutes. Oh no, I got another one. Okay. All right. Solving equations by factoring. So in this one, what they've done is they've already factored for you into your factors right here on the first two. Okay, now notice this is the difference. We're solving because we have an equation. We have an equal sign, so we can actually solve for numbers now with equal signs. Before we were just factoring because they were just expressions. Now we have a step further to do. Okay, so the 4 steps. Let me move these closer together so I can write these 4 steps over here. 4 steps in solving quadratics. Solving. I told you there's, in factoring, there's only 2 steps. Solving quadratics, there's 4. 1 before and 1 afterwards of the factoring. So the first step is set equal to 0. Set the equation equal to 0. We didn't have to do that in the first in factoring because there's no equation. Step 2, factor the GCFs. 2 and 3 are what the factoring ones are. Factor out GCF. Step 3, factor what's left if possible. What's left, that means inside parentheses, if possible. And step 4, set each factor equal to 0 and solve. Okay? So they've already done the factoring for us, so we're on step 4 now on problems 1 and 2. We just have to do step 4. They've already done the first 3 steps for us. So I said each factor, these are called factors. So x equals 0 or x minus 7 equals 0. Notice x equals 0 is already done for me. So one answer is x equals 0. I solve this, I get x equals 7. So if I plug in 0 or 7 into that equation, I will get 0. Okay, so it works. Check it by plugging it back in. Here I set 2. We'll switch the color here. Two y minus 5 equals 0. That's one factor. 2y equals 5 and y equals 5 halves. There's one answer. Or y plus 6 equals 0, and therefore y equals negative 6. There's my other answer. Okay. Now number 3, we actually have to go through the 4 steps on 3 and 4. Okay. So I'm going to go ahead and rewrite it. So number 3, so we have a little more room. T squared equals 5t. First step, set equal to 0. I always want my leading coefficient, my quadratic term, to be positive. So it's positive on the left side, so I'm going to move everything to the left side. T squared minus 5t equals 0. There's step 1. I'll just put in the parentheses for step 1. Step 2, factor out the GCF. There's a t in common. Step 2. Factor what's left. There is nothing to factor. T minus 5 does not factor. So no step 3. And step 4, set each factor equal to 0. T equals 0 or t minus 5 equals 0. Equals 0. This is step 4. So t equals 0 is already done for me. When I solve t minus 5 equals 0, I get t equals 5. And there's my 2 answers. All right, number 4, same idea. D squared minus 4d equals 3d. Set equals 0, so I'm moving it over here. So I have d squared minus 7d, combining like terms correctly. Step 3, factor out the step 2, factor out the GCF. Step 3, there is no step 3, so I go right to step 4, d equals 0 or d minus 7 equals 0. So this one's already done, d equals 0. I solve that for d and I get d equals 7. There's my 2 answers. Okay, is that it? Yes, it is. 23 minutes.